Hey, this is Mr. Barr, and this is the pre-test for graphing functions part 2. Let's get going here. So I need to graph this absolute value function. I know that it's got no shift left to right, but it shifts up 2. Our default kind of equation is y equals x plus h plus k, where the h would do a left-right shift and would appear backwards, and the k would do an up-down shift. So it's going to move it up 2, and then I've got the normal up 1 over 1, up 1 over 1 absolute value shape. All right, same idea here. We're looking at a square root function. So it's y equals the square root of x plus h plus k, where the h does a left-right shift, the k does an up-down shift, and the h is going to appear backwards. So I just have to move this thing down 2. So down 2, and it follows the normal pattern, up 1 over 1. Then it goes, ready, over here it would go up 2 over 4, and then up 3 over 9. I'm trying to take the square root of 1, the square root of 4, and the square root of 9. Okay, our basic cube root function also works the same way. Y equals the cube root of x plus h plus k, where the h value does the left-right shift, and the k does an up-down shift. So looking at this, it's going to move it down 2, down 2. I go up 1 over 1, and then I go up 2 over 8. Why? Because up 1 over 1 gives me the square root of 1, which I know. Up 2 over 8 gives me, the cube root of 1, the cube root of 8. I'm getting to numbers that have perfect cubes. Right, we're going to graph this line. It's just a line that's in mixed up slope-intercept form, so I'm going to make it really look like slope-intercept form for you. There it is. I start at 3, I go down 2 over 1, down 2 over 1. Slope-intercept form, mixed up slope-intercept form. All right, we're going to graph a situation that looks like this. It takes me 2 seconds to climb up 3 meters. Okay, 2 seconds, up 3 meters. Boom. Immediately I start climbing down. It takes me 3 seconds to go down 1 meter. 3 seconds, 1, 2, 3, down 1 meter. Then I wait for 1 second. Wait for 1 second. In the next 1 second, I climb the rest of the way down. 1 second, all the way back down. All right, we need to match this up with one of these. Now I know it's a square root function, right? I know it has a shift of positive 2, which means it's going to be x minus 2. I know it has a shift down 3. There it is. Y equals square root of negative 2 minus 3. Remember, this piece in here is going to appear backwards. It was a positive 2, which means it's a negative 2 inside the square root. All right, we've got an equation that we have to use and plug in numbers and evaluate it. So I was told that so we're given the f's with the table. The mass and the length were given to me in the equation. The mass is 0.01 and the length is 0.5. And I use those two guys to get 0.02. So everything that's going to be down here in the bottom is always going to be 0.02. So I'll take the f, I'll divide it by 0.02, and I'll take the square root of it. So I take the f is 0.05 divided by 0.02, and I take the square root of that answer, and I get 1.58, which rounds to 1.6. I do it again. That glare on my calculator is kind of crazy. Then you can't see it though. If I do that, you can't see the calculator. Okay. So I go 0.2 divided by 0.02, and I take the square root of that, and I get 3.16, which is 3.2. And that's how I do it. I'm going to check all the other ones just in case, see if I made a mistake. 5.2, that works. 11.5, that worked. 14.1, that worked. So using a physics equation, plugging in numbers and evaluating it. All right, let's graph the following absolute value equation. Now, it's an absolute value, it's just in a wrong order, so I moved it around. I moved that 2 behind it because I like it that way better. So this is going to flip it. That's going to move it right 3. So I'm going to go right 3, 1, 2, 3, up 2, and then I have a flipped absolute value, which is just a down 1 over 1, down 1 over 1, down 1 over 1. Flipped absolute value. Ooh, a piecewise function. Highly recommend that you do piecewise functions on a piece of graph paper. It's really difficult to do it otherwise. So this thing's transitioning at x equals 1. So I drew a vertical line at x equals 1. My first graph is y equals negative 3x plus 2. Y equals negative 3x plus 2. So I started at 2. And then I went down 3 over 1. And I hit the border. So I stopped. And then I went up 3 over 1, up 3 over 1. So I got this line right here. And you can see that it's a closed circle right there. The other one is just y equals x plus 3. So I start at 3, and then I go up 1 over 1. And I don't actually draw that piece of the line in because I'm not to that dividing line yet. And now I start the line up 1 over 1, up 1 over 1, and it's an open circle. All right, hey, that's it. I think that's it. That's question 9. So let's see if I can actually get this into Edulastic. This was the pretest. We'll see if I can take the stuff that I just wrote down and get it into Edulastic. Okay, let's graph this. This was an absolute value. Let me get this in here. Start at 2. Oh, I don't have the check answer feature going. Ugh. You know, I'm going to pause it and I'm going to come back. All right, I'm back. And now I can actually check my answers. Good. Okay, next one was a square root function. So we're going to get this in there. And we're just doing this with segments. Next one is the S function, the cube root function. Yeah, my lights just went out. All right, this was a line. It starts at 3 and goes down 2 over 1. Looking good. Okay, let's copy this from my paper. Say on this one we went with D. Physics equation. .6, 3.2, 5.2, 11.5, 14.1, question 8. We're going to graph this. This was a flipped absolute value at 3.2. And then a piecewise function. You know what? This piecewise guy might be unhappy. I know that when I was making other things, they were unhappy. Let's go with on the order. Okay, so we'll have to use the circle tool. And then there's supposed to be a circle right there. Let's check it and see if it works. All right, I'll have to fix this one, or I'll have to hand grade it. You know what? This will probably be a hand grading one. I'll look at your picture. I'm not sure why Edulastic doesn't grade this correctly. All right, that's it. Thanks for watching.